Thanks for joining us for our last session of this workshop. It's about what to do once you've been admitted. I just wanted to thank the organizers, Justine and Nolan, and every one of the presenters and participants here for what I think was a really informative and successful workshop. So let's see, here we go. So this is what we've gone through so far, and I'll bring this back up at the end to encourage anyone with any questions from other sessions to just throw them out. This is throw them out here, and we'll try to answer them as best as we can. All right. So I think the first thing I would like to say is that this has been a particularly challenging year. Very much not normal year for applicants, and what an interesting time to be in your position. Hang in there. This year has been hard. Next year, I have no idea what it will look like, but it'll be certainly very different. But please do reach out, and because you're not alone. We're all figuring it out as we go, and we know that there are many questions out there. So keep reaching out and keep asking questions to us within the workshop, but to the program coordinators as well that of the schools that you're thinking about. They have answers that might be very helpful, and you can ask us now and during this workshop, but certainly you can reach out to later as well. And that's what this workshop is about. All right, so let me tell you a little bit about myself first. So I was born in Argentina and came to the US to pursue science, just generally like that. And I ended up in Texas after going to first to the West Coast and to the East Coast. And I started off studying physics at UC Santa Barbara, and I'm essentially still catching up on my biology here in the Biochemistry and Biophysics department at Texas A&M. So the work I do is basically around protein folding and functions. So how do proteins perform the vital functions that we rely on? How do they find their targets? Some of the questions that I think about are what determines the affinity between a protein and the ligand, and the concept of allostery, which is a word that basically means how proteins can relay information in a very fascinating way. I do all of this with I'm partial to using pressure to investigate these questions, and on the right here I'm showing an image I had in my thesis of this pseudo submarine that went down to the trench in Las Marianas for the first time. So this is 11 kilometers below the sea level, where the pressure is about 1,000 atmospheres. Back in 1960s. So this giant object held 2 people in that little bubble with a window. Took forever to get down there. It was incredibly cold. They ate chocolate to stay warm. Kind of fun fact. I have a friend who, this has been repeated since, I have a friend who tied an egg to the outside of one of these submarines. And I want to see if anybody can venture a guess as to what happened to that egg when it came back. Anyway, so let's see. So we're used to thinking about proteins. We got brought up, at least our generation, thinking about proteins as these. You go to our PDB, the protein data bank. You download a protein structure and you draw it up, and it looks like this. Plate of stale noodles, just a rigid object. And since then, crystallography has become pretty sophisticated and can add some motion to alternative conformations to the side chains. So doesn't look so much like a rock. It looks like a fuzzy rock now. But what we know now and what our lab really cares about is how these proteins are just moving around all the time. So they look more like an air dancer than anything else. And to tap into this, we use something called nuclear magnetic resonance to look at side chain dynamics. And so what I've painted here on the figure on the right is half of a protein that becomes, that responds by becoming more rigid, responds to pressure by becoming more rigid. And another half of the protein that becomes more dynamic. So these spheres in red are moving more at a high pressure, and these spheres in blue less. And if you look at the protein structures, there's no way you can extract that information. You really have to do these dynamics experiments, and that's what we were really interested in. So here's a little drawing I made of a protein that has access to a number of its states. And when it binds a ligand, it loses access to some of these states. And it essentially, this is an entropic concept. It is an entropic penalty that the protein has to pay to bind the ligand. So it's unfavorable in this case. And so what we decided to do is look at a great number of these systems. So here are 28 different protein ligand complexes. And in the red bar, you see this conformational entropy contribution. And the first thing you see is that it varies, right? It goes from very positive numbers to very negative numbers. Our whole endeavor here is to try and figure out why that is. What are the properties? So let's bring back the structure here. What are the properties of this protein that determine whether this will be blue and contribute in an unfavorable way, whereas this is red, contributing in a favorable way? This here can certainly drive binding. It's an important enough term to consider when we think about protein function. So that's us. That's what we do in our lab. We use that's what we do. Okay, so focusing on the workshop here, please feel free to ask me about my research. I'd be happy to chat. With respect to the workshop, this is about the moment after the moment right after you've received an offer. Well, I think that the first thing you should do is take a moment to celebrate, because getting a PhD is pretty unique. You will belong, when you graduate, you will belong to a very select group of people in the world who will have such a title. By statistics from Michigan State, you should achieve a six-figure salary. That's of course on average, but that's a good thing. And within the U.S. itself, you'll be one of just 50,000 people that year to get a PhD across all disciplines, and that's an important workforce to have, this highly skilled workforce. So that's great. You will have till April 15th to accept an offer, and I suggest you take all of those days to consider your options. And if you have multiple offers, I'll walk you through some of the thoughts that will be useful in choosing the right one for you. So I think the first step we should all take is making an effort to separate the name from the school, because there are a lot of really great schools out there that might be not as renowned as some of the top, the ones that rank at the top frequently. And they're very well worth taking a good look at. Particularly because oftentimes rankings can just be bogus. Here's a funny article that I read about how Einstein would be a mediocre scientist based on this H index that people use nowadays to rank or evaluate professors. So we shouldn't go blindly with what the rankings say. But nevertheless, the names are there for a reason. And so the places that rank up there are going to be good. Top 3 and top 30, you know, they're probably going to be really great places. All you want to make sure of is that the research in those places, the research aspect for biochemistry and biophysics especially, has to be good. Otherwise, you're going to be limiting your options severely. And then on a specific note, when you do look at a ranking table, it might consider, you know, average measures. But if you're really interested in doing cryo-EM and the school is really good at NMR, then you're not going to meet each other, right? Okay, so that kind of makes sense. The argument for the other schools is, the other half of the argument is that there are many schools out there that are probably not aware of their full extent of their prestige. So on an embarrassing note, I actually didn't know how amazing Hopkins was when I went there. But you can't blame me for that because I was born in Argentina and lived there for most of my life. So there you go. But you know, you can do your research, your own research, and really find out that places that you weren't necessarily aware of can be really good at research. On another note, you could potentially end up in a less supportive environment because you didn't consider these other schools. I'm not saying that the top ranked schools are not supportive, but I just mean that perhaps the other schools are really good at being supportive. And that might be something that ranks high for you. And then the last aspect here is kind of an interesting way to think about it. I thought, you know, there are different ways of going through a PhD, and there are places that are really trying new things in their approach to teaching and learning. And so here I put a couple examples I know of. This is at the undergrad level mostly, but the College of Creative Studies at UC Santa Barbara and the Meyerhoff Scholars Program at UMBC are doing things very well and in very non-traditional ways. So that's something you want to keep your eyes peeled for. Yeah, okay. So here we get into the more, you know, technical things to ask the program coordinators or people from the program. So for example, money will be a factor. So how much is your stipend going to be? And when you think about stipend, you should also think of the cost of living, because $1 doesn't go as far in a place like San Francisco, let's say. But tuition will be paid in all of these programs. So you will get a salary and you will get your education paid for in a PhD program. However, under the house of how that happens can vary. So some programs require you to do TA-ships, so teacher assistantships, where you have to devote several semesters, 2 or 3 semesters to teaching. And that can take a lot out of your time. If you're into teaching, that's great. I still think that choosing to teach is a better option than having to teach. So that's actually a good bargaining chip, especially if there's other methods of support, if you have fellowships being offered alongside your admission, or if there are programs that you can ask about to try and apply for extra funding or different modes of funding. Again, things you can ask your program coordinators. But probably the most important aspect is the timeline for a PhD. So this funny comic here kind of pokes fun at it, but there is no and time guarantee to get a PhD during. So you want to look at some of the statistics, and here Duke does a great job of publishing all of their statistics with an average of 6 years, I believe, for most scientific STEM-based grad schools. And then, so you can look at that. You can ask for that. I encourage you to, and that's a good metric to compare programs by. The attrition rate is certainly important. It reflects the health of the program. You want to make sure the program you end up at does not let students fall through the cracks very often. Those things happen for various reasons, many various different reasons. But if it's a common thing, that's not a happy thing to claim. Another way of asking about the health of the program is what students do after their program. And programs will push their success stories, but you also want to hear about those rudimentary average stories as well. And chances are that they're going to be landing in good places, and that's what you want to hear. And then, something that they can respond, give you information on as well is how often students and advisors meet. And this varies from lab to lab, but you want to make sure that students are being checked in on by the advisors, but also by other faculty. So if there are thesis committees or review committees of some sort, how often does that happen? Are other faculty making sure that they're involved in the process? So are you being cared for, and are they having a say on your timeline, for example? Can they advocate for you? And then you have questions more for your day-to-day life. So here again, I state about the thesis committee and faculty. But for example, you want to, if you're interested in being involved, actively involved, you can ask about student organizations and other types of activities. You can ask about campus life, and depending on what your personality is like, you might enjoy the busy sounds of an active city like here at Hopkins Medicine, or you'd be happy on the beaches in UCSB, right? So different students will be attracted by different things. It's good to start those conversations and see what it's all about. If the picture is really what life is like. That's a great way to reach out to students, for example, within the program. The program coordinators, again, are there to answer those questions for you. These are the people you will want to reach out to often with your questions. And you can ask about departmental retreats that you get to participate in, outreach programs that the department or specific labs are participating in. This will tell you a little bit about the personality of the labs or the department itself. And then, of course, there are other opportunities that you can ask about. So we talked about fellowships and other sources of support that you can try and apply for. But for example, Hopkins is flanked by several institutes that you can share your time at during your PhD program. So that really adds another dimension to your career. And if you're interested in that kind of stuff, the sooner you know about it, the better your chances are to get involved in and profit from that. As to faculty, I would kind of restrict my questions for faculty to very specific questions. I'm sure they love to interact with students, but like people I've mentioned here before, you don't want to leave a sour impression by asking some campus life thing that students might be better suited to answer or I don't know, maybe you do, whatever. But I would specifically ask, for example, about rotation requests. If you're really into the science that that lab is doing, well, ask if they're taking rotation students, or if there's a particular rotation that works better for them. Maybe that faculty member is teaching the first semester, but will be much more engaging the second semester. So maybe you'll want to delay your rotation with them. And then, you know, with the promise of some interaction once you join, reading up on some reading material that they think might be important to get in tune with what they do. That's a good way to establish a connection. So there, between April 15 and August, September, you'll have some time to yourself. I really encourage you to think about a vacation, especially during these times, to spend some time with your loved ones and care for each other. But also, I cannot remember the last time I went on vacation. So this is a great time to kind of sit back, enjoy your accomplishment, and you know, recover some energy, get ready for a whirlwind that's coming of excitement and work. This is my 2-year-old splashing in a pool. That's exactly what I think I would have done. So, but another thing that you could do is think about science work of some sort. For example, a summer internship might be just as fun if it's in a place like this, for me, personally speaking. I actually did something like that myself. I went to Germany for an internship at LMU in Munich, and it was fun. It was great. I learned about biomaterials, totally unrelated to what I was going to do next, but it was a great experience. Alternatively, if you want to engage the program early, you can ask about summer rotations. Typically, they just add another rotation to your schedule. They don't shift you to a shorter time frame, although that might be a great question for the program coordinator. If that's something you think is for you, that sounds great. Typically, the 3 rotations or so that you get in a program, if you get that, that's a great way of that, and probably enough for you to get a sense of good labs to join. And then, of course, any coursework you might think you should catch up on. For me, that was definitely biology, so I just grabbed a biology textbook and took it along with me. You can take this as to the extreme as much as you want, but it's good to come prepared for sure. And then in some more practical aspects, really reaching out to the current students, because those are the people that you will spend a lot of time with in courses, but also running into and rubbing elbows, and maybe even working next to for the next 5 to 6 years. But you'll also need housing and housemates, and you'll want to know what the good neighborhoods are. So these are great ways to engage them. And typically, programs have students who volunteer to make themselves available. This is definitely a good way to get the answers you're looking for. And then as sort of mental advice that I can give you is that during undergrad, perhaps if you were like me, you were learning in a classroom, kind of jotting down things passively, and what's coming next is definitely going to be not that. So you're going to want to sort of prepare yourself for a very active and engaged way of working and learning. So this is definitely going to be you trying to figure things out for 40 plus hours a week. I can almost guarantee that. Hence the emphasis on vacation. Yeah, so that's more or less all I've got. We have 5 minutes. So I brought back our schedule for the workshop. And if you have questions on any of these topics, now is the time. Is a good time to ask these. We also have a YouTube channel where you can revisit all of these sessions. Just Google TAMU Biochemistry and Biophysics. Thank you.
Awesome. Alfredo, can I toss you a couple questions that we have in the chat
Yeah.
box? Awesome. So earlier you spoke about not only considering the rankings when considering, what a good graduate program looks like for you. So can you give us some advice on other avenues that we can consider when we're saying, what makes a good graduate program other than just the rankings?
Yeah, statistics. I'm very partial to statistics. So you want to look at timelines, where people go after, how well they fare, how happy they are. Any sort of statistic that you can get your hands on, those are facts. You cannot avoid that, right? So the ones that you care about, those are the ones you should follow. And if you're having a hard time finding those statistics, reach out to the program coordinator. A lot of these programs have to keep tally of those things and report to agencies about them, so that they'll be able to provide some information for sure.
Awesome, thank you. So Tristan actually has one harkening back to your research slides. So Tristan asks, what model organisms do you use to source the proteins? Microbes that live deep in the water? I assume this is a reference to your submarine picture.
Yeah, it's fascinating. I personally don't work with weird bugs. I just work with E. coli to make my protein of interest. But there are some people out there that do some crazy stuff, and they pick up organisms in these remote areas, very extreme living conditions, and they have to maintain those in their labs. So they have some really crazy equipment with thousands of atmospheres, crazy pH, temperature. Absolutely.
Awesome. So I have one that wasn't asked, but I think it's an interesting discussion point because I've had the conversation with a few people offline. Can you talk a little bit about stipend level versus cost of living?
Yeah, what can I say? I think for the most part, stipends are designed so that you don't have to sweat it. But that doesn't mean my comment was mostly about trying to avoid the trap that, oh, this place gives me more money, so I should go there. It doesn't matter if they give you more money if your rent is going to be 10 times that of another place, right? Because that's where the money will go. So just to not look at things just at face value, but do a comparison within the means and anyway, the situation.
Absolutely. And actually, I'll just add to that answer really quickly. So one of the other things to consider if you are looking at a graduate program that is in a notoriously high cost of living area, so I know New York City specifically, a lot of the universities out there offer subsidized housing for graduate students. So if you are concerned that the cost of living versus stipend that you're being offered is not in your favor, it may be worth taking a look at options for subsidized housing.
Good point. Right. And program coordinators will love to share that kind of information with you.
Absolutely, yes. Make sure that you're reaching out to as many people as possible. Students are also a really good source of information.
Okay, anyone want to tell me what happened to the egg?
Yes.
Do it.
I'm guessing did it implode?
So it came back just as it went down. Turns out that 1,000 atmospheres to a protein or to most proteins is not that high, that much. So they don't unfold. They generally misbehave. The figure I showed, for example, was to 3,000 atmospheres, so 3 times the depth of the ocean, and the protein is just fine. It just wiggles a little differently in our case. ribosomes fall apart and things like that. But proteins, individual proteins, they do fine. So the egg, which is mostly protein, came back just fine, uncooked, but unbroken. And that's because the shell apparently can exchange well enough with the environment that it doesn't sense the pressure, right? It equilibrates. So that was unexpected when I learned.
That's very exciting.
All right. Well, thank you everyone so much. Thank you, Justine, again for everything, for organizing.
Yes. Thank you all so much for hanging with us for the last 10 weeks. We really appreciate it. And hopefully I will see applications from each one of you in the near future. All right. Thank you all. Have a good one.
Bye.